Welcome back once again. More videos, yay. Alright, so today we're going to continue with exponential growth and decay. We've learned a little bit about the formula, we've done some pieces of it, but now we're going to actually do some real problems. Alright, so we're going to have our starting value, we got our 1 plus or minus our rate, depending on if it's growth or decay, and then we got that exponent of time. Now this formula will hold true unless outside factors or variables change. Let's think about that for a second. The outside factors or variables. So if something changes in the world around us, then exponential growth and decay can change as well. For example, I don't know, wearing a mask? Sorry, kind of had to. Anyway, example. So the population of a town was 30,000 people in 1980. And the population has been increasing at a rate of 2% annually. Now again, that's an average rate. It's not going to be exactly that every year, but that's kind of what happens. Populations usually kind of increase or decrease at a steady rate. So the first thing we want to do is we want to write an equation. All right, so let's do that. So that's y equals, and our starting amount. We started off with 30,000. All right, now we got this rate, 1 plus or minus. Well, if it's growth, it's plus. It's been increasing. I see that key word there, so that's plus. And then that percentage rate as a decimal, 0.02. And now my exponent is t for time. And that's the part that changes. I don't know how much time it has been. Depends on when I want to make a measurement. So that's the next question. What would the population be in 2020? So let's just say that this was a real town, and we want to know what its population is right now. All right, so what we would do is we would plug those numbers in. So we got the 30,000. I'm going to go ahead and do the 1.02. I went ahead and added those. And then t is time. Well, how long has it been? We're measuring in years. How long has it been from 1980 to 2020? Well, that'd be 40 years. So there's my exponent 40. So I'm going to plug that in on a calculator, exactly the way it looks. 30,000, and then a parenthesis, 1.02, and then an exponent of 40. Again, if your calculator does big exponents like this on your phone, that's great. If not, you'll have to use decimals. I got 6,241.1, and again, we can't have 0.1 of a person, so I'm going to leave this as a whole number. So there's my population, 66,241, if the town has got this nice, steady 2% growth rate. All right. Again, that's pretty common for a city to have a small growth rate. People are exponentially growing. That's a whole another lesson, is the idea of the exponential growth of humans. All right, let's try one more. It says the profits for a local restaurant were $50,000 in 2014, but since then they have dropped by 10% each year. So they're not getting as much business as they used to. So let's see how much, or what the equation would be first off. Then we'll find out how much the profits would be down the road. All right, so first off, the equation, y equals. Well, starting amount. Well, it looks like back in 2014 when they started keeping records, they made 50,000. And then 1 plus or minus. So this one, ooh, it dropped. This is a minus. Dropping by 10% or 0.10 or 0.1. And then exponent t. Not sure about the time. That can change. All right, so let's actually find a specific answer. That's what we're going to know, a t. So how much profit in 2025? So again, I've got 50,000, and then 1 minus 0.1, I'm going to go ahead and put that in as 0.9, and then my exponent. Well, how long has it been from 2014 to 2025? So just minus those numbers. It's been 11 years. So there's my exponent, 11 years. So 50,000, and then times, or parenthesis, 0.9, exponent 11, and I am getting y equals $15,690. I'm not going to worry about the cents on this one. I think that's a good enough estimate. So, well, their profits are really dropping. At this rate, eventually they're not going to be making any profits. So they might need to think about making a change to their business. Maybe change the menu, change locations, change chefs. There's a lot of different things a company could do, but people absolutely look at these numbers. People absolutely do things like this in the real world. They try to use this to predict the future, what's going to happen next. Obviously, we could do COVID problems like this until we were blue in the face. This is exactly the kind of thing that you've been seeing in graphs for the last 8 months on TV when they talk about infection rates and things like that. So maybe down the road we'll have a little lesson that brings the COVID into our work. But right now, let's kind of try to keep from overkilling that topic too. All right, this is your assignment today, is stuff like this. You know how to get a hold of me if you need any help. Good luck.